You now see text extraction in action. I'll take a photo of the book cover. The section I'll be extracting is iOS test-driven development by tutorial. And then I'll click on Keep Scan. Save. And as you can see, the text has been extracted from the book iOS Test-Driven Development by Tutorials. And we can also copy the text on the clipboard by clicking on Copy the Clipboard button. In your SwiftUI project, create a new struct called Scan Document View. Select Swift File, click on Next, and then enter the name Scan Document View. And then we need to import SwiftUI, import VisionKit, import Vision. Next thing we need to do is to create our struct, which is called Scan Document View. And this struct will implement UI view controller representable. And the purpose of implementing UI view controller representable, it allows UIKit view controllers to be used within SwiftUI. Next thing we need to do is add our environment. And the reason why we need to add our environment is to enable our current view to be dismissed, as in hidden, when the user no longer needs it. So that should be presentation mode, presentation mode. The next thing we need to do is to add a binding variable at binding bar recognized text, which is string. And that is the text that will be extracted from the content view and then passed into the scan document view. And we need to add another function called make coordinator. Coordinator recognize text, $ recognize text, parent self. The next function is called func make UI view controller. That returns a VN document camera view controller. So it enables the camera view to be displayed on the screen. Let document view controller equals new VN document camera view controller. Document view controller dot delegate equals context dot coordinator. Return document view controller. And then we also need to add another method that's called update UI view controller. But this method does nothing, doesn't do anything. But it needs to be included since we're implementing the UI view controller representable. So because this class that we're implementing includes these methods, we have to fulfill the contract within the scan document view struct that we're implementing now. The next thing we need to do is to create a class. The name of the class is called coordinator. That implements the NS object. VN document camera view controller delegate. Next thing we need to do is implement the initializer. And pass in the following parameters, which includes recognize text, binding, string, parent, scan, document view. Self.recognize text equals recognize text. Yeah, that shouldn't be override on lines number 33. It should just be in it. I recognize it's spelled incorrectly, so let's refactor that now. Should be RECOGNISED. And then also we need to correct the spelling mistake here as well. Recognize. Recognize text. Let's see if this fits it. No, that doesn't fit it. I'll just enter it again. It should be recognize text. $, recognize text, parent, self. If there's an error somewhere else, where is it? Recognize text, recognize text. $, recognize text, parent, self. And we'll just fix those errors afterwards. So let's go into the coordinator class. Type in the following: var, recognize text, binding, string, var, that it should be var, not bar, var, parent, scan document view. And then within the initializer, we need to assign our parent to the incoming parent. And the purpose of that is to initialize the coordinator with the recognized text and the parent view. The next function we need to add is the document camera view controller. The one that includes the did finish with parameter. And the purpose of this delegate method, it's needed to be implemented so that the view controller can be dismissed after the scanning operation has completed. So we need to type in the following: let abstracted images equals abstract images. So the next thing we need to do is implement the extract images function. File private function extract images from scan vn document scan, which returns an array of CG image. Next thing we need to do is to create an empty array to store a list of extracted images. And now we have our image that we have scanned. So we need to loop through each page that's been scanned. And then get the image of that page that has been scanned. Scan.image of page at index. So if there's like 2 pages, the index would be 0, then it would be 1. Or if there's like 3 pages, it would be 0, 1, 2, 3. Now that's for 4 pages. If there's 3 pages, it would be 0, 1, 2. So now we have our extracted images within our array. The next thing we need to do to check if the extracted image has a CG image representation, let CG image equals extracted image.cg image. Continue. So what it does, if the image doesn't have a CG image representation, skip to the next iteration. So it just keeps on going around the loop until it finds one. And then when at least one has been found, we then add the image onto our array of extracted images. And then we just return the result to the calling routine. Extracted images. On line 47, we need the more than sign, more than symbol, because we're returning a value from the function. The next thing we need to do, we need to return to our document camera view controller function, which is this one here. One of our delegate methods. And then we need to continue the implementation of this function. So it should be from. So we pass in the image. Or we pass in the scan information to the extracted images function. Let process text equals recognize text from extracted images. Recognize text dot wrap value equals process text. The purpose of that line, it will update the recognize text binding. And then the next thing we need to do is to dismiss the parent view. Parent dot presentation mode dot wrap value dot dismiss. And then the next function we need to create is, it's called recognize text. So type in file private func recognize text from images, CG image, that should be image, CG image, that returns a string, so the string is the actual text that's been extracted or recognized. Var entire recognize text let recognize text request equals vn recognize text request error in. So that's for our closure. And then the next thing we need to do is to check for any errors that we may have. If there's any errors, we just exit. Else there's no errors, so we try to do the next command. Guard let observation equals request results as vn recognize text observation else return. So what that line does, it retrieves the recognized text observation, but if it cannot retrieve any of the recognized text using observation, then it just returns on the function. Else, it's found something, and then we do the following. Let maximum recognition candidates equals 1. Since we've found at least one, we need to iterate through the observations, go through the actual collection. For observation in observations, on line 80 there should be observations with an S at the end, because here we're retrieving an array. That's why it's got open bracket, close bracket. So we're looping through the observations array. And then we attempt to retrieve one of the top candidates from the observation. guard, let candidate equals observation, top candidates, maximum recognition candidates, dot first, else, continue. So it gets the first candidate that you can find. So the candidate, that's the actual text that's been extracted from the image. So now we have some of the text that's been extracted from the image. We use our entire recognized text variable, and then concatenate all the instances of the found recognition text or observation extractions that's been removed from our image. Candidate dot string, and then we just add a new line character. Then the next thing we need to do is, after line 91, add the following. Recognize text request. Recognition level equals dot accurate. So for us at the moment, accuracy is more important when doing the extraction and speed. But if we wanted to, I think we can base it on speed. Yeah, fast, that's the speed of it. If you want it to be done quickly. But we want accuracy, like the right information. For image, in images, let request handler equals VN image request handler CG image options empty array. Try request handler dot perform open bracket close bracket recognize text request. And what that does, it performs the text recognition on the current image and then returns the entire recognized text to the calling routine. Now let's compile it. So there's still an error there. Xcode crashed, so I had to restart Xcode again. But now it seems like the error has gone. So I'll just reindent everything. And then compile it again. In next week's tutorial, we will implement the content view so that the content view will call the struct that we created in this tutorial to display the scanning view, the scan document view. You will now see text extraction in action. I'll take a photo of the book cover. The section I'll be extracting is iOS test-driven development by tutorial. And then I'll click on Keep Scan. Save. And as you can see, the text has been extracted from the book iOS Test-Driven Development by Tutorials. And we can also copy the text on the clipboard by clicking on Copy the Clipboard button. In this tutorial, we will implement the content view to enable the scanned document view to be displayed so the user can extract information from their document or image. Within your content view, enter the following: @state private var recognized text equals press the start scanning button. @state private var showing scanning view equals false. The purpose of showing scanning view, the Boolean variable, is to show and hide the scan document view. Let button height CG float equals 50. So that will enable the button heights of the two buttons to be the same height. Just to make the UI a little bit neater. We can delete lines 18 to 21. On line 17, enter the following: navigation view. Within the V stack, we need to add a scroll view, and then we need to add a Z stack. And the purpose of the scroll view is to enable the user to scroll their text, because the user could scan any amount of text, like very large text. Rounded rectangle corner radius, and that should be corner radius 20, style continuous. Dot fill, whites, color whites. Dot shadow, radius 3. So what we're doing here, we're displaying a rounded rectangle with a shadow contained within the recognized text. And then we need to add our text element that includes our caption that we want to be displayed, which is press the start scanning button. Dot padding, we can delete the padding on line 35, this one here. We also need a padding after line 31. Spacer, and then we need to create a H stack. And the H stack will include the buttons. And it also includes 20 pixel spacing between each buttons, which is here. So now we'll add each button, action, that should be capital B for button. Self dot showing scanning view equals true. Next thing we need to do is add a caption to our button, which is start scanning. Add a frame so that both of our buttons are the same size. Frame, max width, infinity, min height, button height. padding, foreground color, dot white, background, capsule, dot fill, so that should be capsule, color, blue. So now we have our start scanning button. Oh yeah, and we need another closing bracket at the end on line 46, this one here. So now we need to create our next button, which is to copy to the clipboard, copy the contents of the text extraction to the clipboard. So I'll just copy and paste that button and paste it anywhere after line 47. And then for the caption of the next button, which is this one here, I'll call it copy to clipboard. And then within the button action, that should be self.copy to clipboard, but we need to create that method first. So let's create the method first. Anywhere after line 62, private function copy to clipboard. UI paste board dot general dot string equals recognized text. The text that we have extracted will be copied to the clipboard. So now we can call the copy to clipboard method. And then on line 56, just change the color from blue to green for the background. And we only want to enable the copy to clipboard button if there is something to be copied. So if the recognized text variable contains text, then enable that button so that the user can click on it. Tap button to start scanning. On line 16, we just need some more padding. And then on line 60, after line 62, we just style the background. Dot grey, dot opacity, 0.1. Dot navigation bar, title, document scanner, and then the next thing we need to do is to display the action sheet is presented $ show scanning view. Showing scanning view. So if that's true, then we will show the scan document view. And then pass the recognized text to the scan document view. Well, there should be a $ there. Just compile it. The next thing we need to do is to add a key to our info plist to enable the camera to be displayed. So to do that, click on your project name. My project name is called Text Recognition Tutorial. And then click on Info. And then add a key. To add a key, you hold down the Control key and then left click on your mouse button and then click on Add Row. And the key we need to add is called Privacy Camera Usage Description. You can select it here from the list. And then within the string value, for the string value, just enter a little description. For example, this app needs to use the camera. We can enter anything, really, whatever you want. And then now I'll just compile it. To test the application, you have to test it on an actual physical device, such as an iPhone or iPad. You can't test it on the simulator. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. In this tutorial, we'll be using Vision to extract faces from an image and include the extracted faces within a list. As you can see, within this image there's 3 faces and each face has been extracted and displayed within this list here. So this is what we'll be doing in the tutorial today. Within your SwiftUI project, create a new Swift file and then name the file Face Detection. Next thing we need to do is to import Vision and UIKit. And now we need to create our class that's called face detection. Public class face detection. The next thing we need to do is to create an array. The purpose of the array is to store an array of faces, or to detect an array of faces when they're found within the image. Private var detected faces UR image. Next thing we need to do is to create our default initializer, public init. Now we need to add a method that's called convertImage. It's private func convert image face image, and the data type will be UI image, which can be optional, and it will return a UI image. Which can be optional as well. Next thing we need to do is to check that the image exists and can be converted to the correct data type. Guard let image equals face image, let data equals image dot png data, else return nil. So lines 20, what that means, if the image cannot be converted to a UI image or a PNG image, then it will return nil. Else, if the image can be converted to a UI image, then it will do the following. It will return the converted UI image. The next method we need to create is called face detection. Public function face detection document UI image, optional. Now we have to perform some safe unwrapping by using another guard statement. So that's guard let face image equals convert image, the document, which is the image, let CG image equals face image .cg image. Else, if it cannot be converted or some error happens, just come out of that method, just return from that method. Next thing we need to do, we need to create a face detection request. So we type in let request equals VN detect face capture quality request. And then we need to add a weak self to release the memory, and we need to call another method afterwards within the same function, which I'll be doing in a minute. Request in guard let observations equals request results as VN face observation, else return. Line 36, what that does, it checks if the face observation results are valid. If it's not, then it just returns out of the function. The next thing we need to do is to loop through all of the extracted faces that were found. So just type in for observation in observations. If let cropped face image is equal to self dot crop face image, so we need to create another method called crop face image. So let's create that method first after line 45. So just type in private func crop face from image. And then that function needs to accept two parameters, which are image, which is the UI image, using observation and observation, which is a VN face observation data type parameter. And this function will return the cropped image as a UI image. It can also return nil, so we need to use an optional there. as a question mark. And then on lines 52, just type in return nil. And then we go back to the previous function that we was in, which is face detection. And on line 40, just type in crop face from image, and then provide the parameters, which are face, image, which is using observation, and so we need to include the bracket there for this statement. There's an error on line 421. I think it's face image. Oh, we need a comma. There should be a comma there. Using observation, and then you just pass in observation, which are the extracted faces. And now that we have the extracted faces, we just append the extracted faces to our detected face array. The next thing we need to do is on lines after line 45, is to create a handler for the image request. So just type in let handler equals vn image request handler cg image options and then now we need to create some error handling using do block, and then we need to add a catch there, and then just print out any errors that might happen. And then within the do block we need to add try handler dot perform request. And the purpose of this is to perform the actual face detection. I'll just compile it now just to see if there's any errors. Just compiling at the moment. It's compiled. So the next thing we need to do now is to complete the implementation for the function crop face from image. On lines or after line 59, just enter let image size equals image dot size, and the purpose of that is to get the size of the image. Let bounding box equals observation bounding box, and the purpose of that line is to get the bounding box of the detected face. Let x equals bounding box dot origin dot x times by image size dot width, and the purpose of that line 64, is to calculate the x coordinates where the cropping should start. So that's where the actual face is located and where it will be extracted. The next thing we need to do is type in let y equals 1 minus bounding box dot origin dot y minus bounding box dot size dot height times by image size dot height. And the purpose of that is to calculate the y coordinates where the cropping should start. Let width equals bounding box dot size dot width star image size dot width, and that calculates the width of the cropping region. And the same thing, I'll just copy and paste this one, because the height one is similar to the width. We'll just change the variable name, put height here and height there. And then what we need to do, we need to type in if let CG image equals image.cg image question mark dot cropping CG rec which is x, y, width and height. So we need all of these parameters. So CG rec, assign x for the x parameter and y, and for the width, just type in width, and for the height, just type in height. Return UI image CG image CG image. So the purpose of line 72 is to crop the faces from the image using the calculated coordinates and dimension. And then line 73, it just creates a new UI image from the cropped image. And then that will return the result to the caller. The next function we need to create is called get detected faces, which is a public function. Public function get detected faces. And this function will return an array of faces that we saw earlier in the beginning within the list, when I showed the list that included 3 faces. That's an array of faces from the cropped image. And then we just return the detected faces. Let's compile it again. It's compiled, so that's good. So next week we'll be adding the interface to enable the extracted images to be shown to the user within the list. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Today we'll be continuing with the face extraction detection tutorial to extract these 3 faces and then put these 3 faces within the list as seen here. Within your SwiftUI project, drag a photo that includes 3 faces and then drag it onto assets. And then drag another picture that's not a human face, for example, an animal, a dog. Just trying to drag it at the moment. It's not dragging. It's not dragging. So now, as you can see, I have 2 images. One that includes a picture that has 3 human faces, which is this one here. And then another picture is a picture of a dog, which is here. So when we perform the face extraction for the human photo, it will retrieve 3 faces, extract 3 faces from the image, and the count will be 3. But when we try to do it with the animal, the dog, the count will be 0, because it's not a human face. So in your content view, you need to create and enum. And the purpose of the enum is to store and reference the base images that we're going to be using, or the pictures that we're going to be using. So just type in enum, my images string, case, 3 faces is equal to 3 faces.jpg. Case, no faces is equal to dog png. And then next thing we need to do, after line 15, we need to add a few @state variables. So just type in @state private var count of faces int 0, @state private var detected image UI image, which can be nil, so it's an optional. @state private var face detection, which is the class that we created last week. So create a new instance of the face detection class. @state private var detected faces UI image, or detected faces was spelled incorrectly, so that should be detected faces. So that's an array of detected faces, which is an array of images, UI images. The next thing we need to do is delete the following from the VStat from lines 23 to 26. Also delete the padding. In the VStat we need to add a text element, face detection, font, large title, font weight, bold, dot foreground color, dot blue, dot padding, top 20. If cell dot count of faces is equal to 0, so if there's no faces, text, no faces detected, dot font, title, dot font weight, bold, dot foreground color, red, dot padding, top 20. Else, if the count was more than 0, that means a face was found. That means a face was detected. So within our else statement, we need to do the following. Else if let image equals UI image name my images, got 3 faces, it should be a smaller A instead of capital A. Do that again, 3 faces, got raw value. Let's get in the name of the 3 faces, .jpg, that's the raw value. So it gets this part using the raw value and then assigns it as the image name here. But really, we should be getting the image from the camera or from the photo library. But for this tutorial, the image names, they're just hard-coded using variables. Image, UI image, image, dot resizable, dot aspect ratio, dot width, dot frame, max width, infinity, max height 200, dot padding, dot top 20. Now, after lines 44, we need to add another text element. Which will show a count of the amount of faces that has been extracted from the image. Dot font, dot title, dot foreground color, dot green, dot padding, dot top 20. And then now we need to add our list. Detected faces. Let's do array ID backslash self face image in image UI image face image. So it's going through the loop and adding each image to the list. Dot resizable, dot aspect ratio, dot fit, dot frame, max width, dot infinity, max height 100 dot padding dot top 20. And then we're typing dot list style plain list style. And then after line 60, typing dot on a pair. Next thing we need to do is to add our detect face method that will be called as soon as the form, as soon as the screen is displayed, it will be called within on a pair. So after line 65, add the following method: func detect faces if let image equals UI image named my images 3 faces raw value. So the first time when we try to run the app, we'll be using the 3 faces image to test the face extraction functionality. Detected faces equals open bracket, close bracket. That just dereferences the array, so it moves everything, deletes everything from the array. So the array will be assigned to 0 elements. Face detection dot face detection document. So we're going to pass the image to the document of the face detection. Detected faces equals face detection dot get faces. Self dot count of faces, and it should be lowercase a, so let's rename that. Go to the definition, and it should be lowercase. Equals detected faces dot count. So if there's a face to be detected, or if the image can be read, it does this block. If the image cannot be read, then we need like an else statement. And then just for testing purposes, we just type in print image not found, which will be displayed to the console. Let's go back to the dot on a pair on line 61, and then apply our new function that will be called, which is detected faces. Detect faces. Add some padding, background, color, dot system, background, dot edges, ignore safe area. Let's run it and see if it works or not. So the output on the screen should be 3 faces as the count, and the 3 faces should be extracted from the image and displayed within the list. There's a over there that should be small a. So yeah, I'll try it now. So we need to rename this instance of count of faces variable. So that should be a small a as well. Let's try to run it again. As you can see, it found 3 faces that's been extracted from the image. Now let's try with the dog image. So all we do is rename 3 faces to be no faces, and then within the detect faces function on line 69, just rename 3 faces to be no faces. So the output should be 0 faces, because the dog isn't a human face. Yeah, that's correct. Face detection, no faces detected. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to turn audio into text easily in your iOS apps? Let me show you how with Swift and SwiftUI step by step. This is the tutorial we will create, and this is the audio file we'll be using. I'll play the audio file right now. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. That is the text that we'll be extracting from the audio file. As you can see here, I will demo it by clicking on the Start Transcription button. Now it's processing the text, it's extracting the text from the audio, and this is the text that's being extracted from the audio. So this is the functionality we'll be creating in this tutorial. The first thing we will do is to add a new function to our content view. The name of the function is called Start Transcript, and the purpose of that function is to enable the text from the audio file to be extracted. We also need to add some imports, so let's add the imports first. Import speech import AVFoundation. Func starts transcription async. The next thing we need to do is to create a new variable called audio file URL, and then we extract the audio file from our bundle for resource. The name of the audio file is called audio. The extension that we're working with is MP3. The next thing we need to do is to convert the file to a new file name. So we need to type the following: converted file URL equals file manager default temporary directory appending path component. And then the name of the temporary file will be called converted M4A as a file extension. And then each time when the application loads, we need to remove the converted file. So that there's no conflicts when trying to convert the file each time. So we remove the old converted file. But now we need to create a new method called remove file, so that the original converted file can be deleted. Function remove file at URL. Let file manager equals file manager dot default. And now that we've created our file manager object, we can interact with the system. If file manager dot file exists URL path. So it checks to see if the file exists, which is the converted.m4a file. If it exists, then we create a do catch block, try file manager, remove, and then we remove the file at the given URL. And then we attempt to capture any errors that might happen. Error removing file. Error.localize description. Now I just compile it. So now we need to return to line 23. And then to indicate that the transcription has been processed, we need to set a Boolean variable. So we need to create a Boolean variable called it's processing. And we do this anywhere after lines 12. At state private var is processing equals false. And we also need another at state variable to handle the progression of our progress bar. Private bar progress double equals 0.0. And now we can set is processing to true. And the progress is equal to 0.0. And then now we need to add another do block. And what we need to do now is to convert the MP3 audio file to an to an M4A file. So we need to create another function. But I'll just put a comment here for later. Try await. Convert MP3 to M4A. So that will be done later. And then to make it easier, I'll just create the empty functions now. So I'll create the convert MP3 to M4A function. I'll do it right now. And then implement them later. So after lines 52, add the following function. Function convert MP3 to M4A. And this function will accept the URL, input URL, data type is URL, and an output. URL, and the data type will be URL, and then it could throw errors. And now I'll go back to lines 35 and then pass the relevant parameters. Convert MP3 to M4A. So we pass the audio file URL and the converted file URL. And we also need to create another function that's called simulate progress increment. And the purpose of that function is to simulate or show the progress of the extraction of the text from the audio file. So we show the progress within a progress bar. So now let's just create that function, the empty function, which is func simulate progress increment, and we will implement that function later. So let's go back to lines 35. After line 35, let's call the simulate progress increment function. We also need to add a transcription result at state variable. The purpose of this variable, we need to add it at the top, is to capture the results of the transcription when it's been extracted, when the words have been extracted from the audio file. Transcription result, which is a string, and it's an optional. After line 38, enter the following: if let transcription. So we just check to make sure that the transcription isn't nil. It contains a value. Giving safe unwrapping. But we need to create another function that's called transcribe audio. So let's create another function. Function transcribe audio, transcribe audio file, which will accept a file URL which will be asynchronous. and returns a string, which can be optional. So I'll just enter return here, just to return something. And then now we have to return back to line 40, and then continue with our safe unwrapping. Just copy the function. That should be file. And then I just pass the converted file URL to the transcribe audio file function. And then we just capture the results of the transcription, which is the text extraction from the audio file. But if an error happened or it cannot be transcribed, then we display a little message. So the transcription results will be failed to transcribe audio. And then we capture any errors within the catch block. Error dot localized description is processing is false, as we are no longer processing. The transcription has finished. So because the transcription has finished, we set the progress to 100% for the progress bar. I'll just compile it now. So it's compiled. In next week's tutorial, we will complete the implementation for the function convert MP3 to M4A. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to turn audio into text easily in your iOS apps? Let me show you how with Swift and SwiftUI step by step. This is the tutorial we will create, and this is the audio file we'll be using. I'll play the audio file right now. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. That is the text that we'll be extracting from the audio file. As you can see here, I will demo it by clicking on the Start Transcription button. Now it's processing the text, it's extracting the text from the audio, and this is the text that's being extracted from the audio. So this is the functionality we'll be creating in this tutorial. In this tutorial, we will continue to implement the Convert MP3 to M4 array function. So within your function definition, within the content view, type the following: return, try, await, with, check. Throwing, continuation, and the reason why we need to use the with, check, throwing, continuation is to bridge the gap for the callback based API to async and await. The next thing we need to do is to create a AVA set for the input of the MP3 file. Let assets equals AV assets URL, input URL, and the next thing we need to do is to create an export session for the AV asset using the M4A preset. So we type in let export session equals AVA asset there should be two S's should be there. Export session, and then we pass our asset, and then we pass our AVA asset export preset Apple M4A constant, and then if there was an error within the session, then we throw this error payload back to the calling routine. Continuation dot resume throwing NS error. For the domain we use a string called export session for the error. And for the error code, we just enter -1. The user info will be NS localize description key. And then the error message will be failed to create export session. We can delete the bracket on lines 94, don't think we need it. And then we use a return statement. To exit the function because an error has happened. After line 97, we type the following: export session dot output URL is equal to output URL. And what that does, it sets the output URL for the converted file. Export session dot output file type equals M4A. And then the next thing we need to do is to start the export process asynchronously. Export session export asynchronously. Switch export session status case.complete. Which means the export was successful. And then we call continuation.resume. Case.failed means the export was unsuccessful. Continuation.resume export session error NS error. So on lines 109, if the export session error exists, it will use the error message, else it will use a NS error. Domain, for the domain, it will be what we've done previously. Export session, the code will be -1. User info will be similar to what we've done previously, which is this one here on line 92. Just need to change the string, which should be unknown export error. And then within our default, if there's any other error that we don't know about, then we just catch it within the default. Continuation.resume, throw in NS error, domain, export session, code -1, and then the user info will be similar to what we've just done previously, but a different string again. Unexpected export session status. On line 107, there should be a colon. I'll just compile it now. There's a missing bracket, which should be here. Compile it again. Compiled. In the next tutorial, we will implement the transcribe audio file function. And the purpose of that function is to extract the actual text from the file and then return the string. So that is for the next tutorial. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to turn audio into text easily in your iOS apps? Let me show you how with Swift and SwiftUI step by step. This is the tutorial we will create, and this is the audio file we'll be using. I'll play the audio file right now. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. That is the text that we'll be extracting from the audio file. As you can see here, I will demo it by clicking on the Start Transcription button. Now it's processing the text, it's extracting the text from the audio, and this is the text that's being extracted from the audio. So this is the functionality we'll be creating in this tutorial. In this tutorial, we will implement the transcribe audio file function. The purpose of the transcribe audio file function is to convert the extracted audio into English text. So within that function, type the following: return try await with check continuation. Continuation. And then within our closure, we need to request authorization for speech recognition. And we use the with check throw continuation to bridge between async await and the callback APIs. SFS speech recognizer, request authorization, author status in, and then within this closure we need to use the guard statement to check if authorization was granted. Guard author status authorized. So if it's authorized, then everything is okay. But if it was not authorized, we throw an error using continuation. Which is an NS error. And then for our error, we need to add a string for the domain, which is called recognizer. For the codes, assign it as -1, user info, will be NS localized description key. Speech recognition not authorized. We can delete the bracket on line 72 as we don't need it. And also the other bracket on line 72. Also, on line 72, there's one bracket type. It should be this one. Should have two of these. And then after lines 74, we need a closing bracket. The next thing we need to do is to initialize the speech recognizer with the specified locals. As I said earlier, the text will be converted to English that's being extracted from the audio. Speech, SF, speech recognizer, local, identifier, ENUS, or GB. The next thing we need to do is to create a recognition request for the given audio file. Let recognition request equals SFS speech I think it's SFS speech URL recognition request, the one with the overloaded URL, and then we pass our file URL, and then this is where we start our recognition task. To extract the text from the audio and convert the text into English. Recognition request. And then within this closure, we need to use or capture results and error. If let error is equal to error, check to see if there's an error or not. So if there was an error, then we just return the continuation.resume with throwing and return the error back to the calling routine. Else, if let result equals result, so there's no error, everything went okay. And now we have the transcription result. Result dots best transcription formatting string or formatted string. The next function we need to create is the simulate progress increment function. The purpose of that function is to update the progress bar when the text is being extracted from the audio. So we'll implement that function anywhere after line 94 or 95. Function simulate progress increment. Dispatch queue. Global async. To make sure we're on the right thread, which is the background thread. And then the next thing we need to do is use a loop while self dot progress is less than 100%. Now we update this on the main thread, which is the GUI thread. Main async. Self.progress equals min max self.progress. It increments the progress bar in sets of 5. Up to 100%. And now we just pause or simulate a pause on the progress bar. So that the user can see that it is actually progressing in steps of 5 to 10. So it just sleeps every 0.2 seconds. I'll just compile it. Xcode is running very slowly. In next week's tutorial, we will implement our content view that will enable us to call the functions to transcribe our audio and extract the text from our audio and display it onto the view. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to turn audio into text easily in your iOS apps? Let me show you how with Swift and SwiftUI step by step. This is the tutorial we will create, and this is the audio file we'll be using. I'll play the audio file right now. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. That is the text that we'll be extracting from the audio file. As you can see here, I will demo it by clicking on the Start Transcription button. Now it's processing the text, it's extracting the text from the audio, and this is the text that's being extracted from the audio. So this is the functionality we'll be creating in this tutorial. In today's tutorial, we will implement the content view to enable the extracted text from the audio file to be displayed on the screen. Delete line 19. Type the following: navigation view, VStack, spacing 20, as you want each element to have 20 spaces. Text, audio transcriber, just little title for the view. Font, dot large. Font weight, bold. Padding. If it's processing, so if the processing condition is true, then we need to display the VStack. And then within the VStack, we need to display the progress view to show the user the state of the progress, which will be up to 100%. Dot progress view style linear progress view style. we need the tint 1 dot blue, padding dot horizontal, text, processing, and then we make sure we convert the processing value to an int. Dot font headline dot foreground color, blue, else if it's not in processing mode, then that means we have the result already. Else if let result is equal to transcription result, so if there's a value in the result, scroll view display the results using the scroll view and a VStack. Alignment dot leading, spacing 10, text, transcription results, font dot headline, text, result, dot font, dot body, dot multi-line text, alignment, dot leading, add some padding, set the background color, to grey with opacity of 0.2, corner radius is 10, padding dot horizontal. Else we display a button to give the user the option to run the transcription audio all over again. So the button caption will be tap the button below to start transcribing the audio. Font, body, foreground color, dot grey, dot multi text alignment, center the button, padding, not horizontal. Add a spacer. If not, it's processing. And we create a button. Within the button, we use a task, await, and we call start transcription method. The button will have a caption called start transcription. Font, got a headline. Foreground color, which is white. Padding, frame, max width, infinity, just to make sure each of the buttons are the same size. Dot background, color, blue. Dot corner radius, 10. Dot padding, horizontal. And the next thing we do, we use another if statement. If transcription result is equal to nil, then create another button and give the user the option to rerun or reset to execute the transcribe functionality again, to transcribe or extract the text from another audio file. But this button is optional, it's not really needed, but I just add it. Headline, dot foreground color, white, dot padding, dot frame, max width, infinity, background, color dot red, corner radius, 10, padding dot horizontal. We also need to create our reset function. We'll do that in a minute. Navigation, title, transcriber, navigation, bar, title, display mode, inline. Now let's create our our reset function. Function, reset. Reset our transcription result, instant object. We reset it to nil. And also our progress. For our progress bar, we reset it to 0.0. It's processing. It's false. So at the moment we don't have any transcriptions processing. On line 89, it should be in line. Also, we missed out the caption for the bottom, which should be reset. Let's compile it. Also, remember to add your audio file, which is this one here. Remember to add it to your assets. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week.